Welcome, science friends, to lipids. Lipids use carbon, hydrogen, and oxygen. Lipids are usually known as fats, so oil and butter, fats that we're usually comfortable with and know about, but they can also be steroids, so natural steroids and as well as synthetic steroids, and phospholipids. We're going to learn more about phospholipids when we talk about cell membranes. Now, the monomers of lipids, there are two different pieces to a lipid, and they need to come together to form a lipid macromolecule. So unlike our carbs, where we have the same repeating sugar over and over and over again, for our lipids, we need two different pieces. We need one glycerol and some fatty acids that attach. Depending on the type of lipid, we can have more or fewer fatty acids, but we definitely need a glycerol and some fatty acids. The example here is a triglyceride. We say tri because tri means three, and this example has 3 fatty acid chains. We can also have lipids with fewer, like a phospholipid has 2 of those fatty acid chains, but depending on the molecule, we can have a different number of those chains. The function of a lipid is to store energy, like long-term energy. So unlike the carbs that's quick, lipids is a long-term storage solution. Another important function is that they form membranes, like I mentioned with those phospholipids. They also are hormones, like steroids, and they keep us warm. They're a form of insulation. So when you think about a whale, whales have a lot of blubber and fat. Well, that fat is lipids that help keeps those whales warm in the cold water. Some examples of lipids are fats and oils, cholesterol, estrogen, testosterone. Lots of different types of lipids are out there. An important thing to note, fats and lipids are non-polar, so that means they are hydrophobic. They do not like water. They don't mix with water. They are not friends. Saturated fats are one type of fat. All of the carbons in a saturated fat are bonded to a hydrogen, and it has the maximum number of possible hydrogen atoms. So if you can see in this diagram up here, we have our central C chain there, and we have all of those hydrogens attached to all of those carbons, making sure that every carbon is bonded to a hydrogen. Please also note that we don't see any double bonds. There's only one line between each of those molecules, those H's and C's, and this creates a really long and straight chain. This is seen in a lot of animal fats, like butter, and the fat in like on your steak or your pork chop. It's really important to note that saturated fats are solid at room temperature, and that's because of how well those chains stack on top of each other. It's pretty easy to stack things that are straight. Saturated fats, because they're solid at room temperature, can sometimes lead to cardiovascular disease. So if you eat a lot of bacon and butter, it's going to start clogging up some of your arteries if you get older and you continue eating a lot of that saturated fat. Unsaturated fats are seen here in this diagram right here, where we see there's a little bit of a bloop, a little turn, a little kink in there, where we see a double bond. So those 2 lines between those 2 carbons show us that there's a double bond. That means that we don't have a straight chain like we saw with the saturated fats. The unsaturated fats are usually fats we find in plant and fish, so corn oil, sunflower oil, all of those fish oils. They're liquid at room temperature. So all of the liquidy fats, they are unsaturated. And that's because that little boop, that double bond, means that our chains are not straight, so it's harder for them to lay flat next to each other. So it's not able to be solid at warmer temperatures. That was lipids. I hope it helped.